So if you watch the perfect square trinomial explained video, that's up here. It will be a link on your page. You'll know that to figure this out, I'm basically just going to take half of this value, which is 5, and square it. So in the blank, it's going to be 25. And that would, of course, correspond to the binomial b plus 5 squared. We know that this sign and this sign will match. And this number will always be whatever half of that was. It'll always be whatever the square root of this is. That's the blank, that's the binomial squared. So we're going to start this off by just talking about what a perfect square trinomial is. And to talk about a perfect square trinomial, a perfect square means it's something that I got by multiplying it by itself. You know, if you could multiply something by itself, wherever you land, that's a perfect square. So these are all a bunch of binomials. They're just two terms, w plus 3, w minus 5, x plus 1, m minus 4, and we're going to square them all. So take a moment to just take out a pencil and paper and write down what you'd get if you squared these. Okay? I'm going to pause the video and I'm going to the answers are going to, when you press play, all the answers will just pop up here, what you would have gotten. So pause the video now and be ready for some magic, I guess. Yeah. So hopefully your answers look something like this, and if you are missing this middle term, I'm going to bet that you forgot that squared means multiplied by itself, and so we are going to, like this 6w, for instance, is coming from this 3w and this 3w being combined. So here's the deal. These are all perfect square trinomials. Then they're perfect square trinomials because each one of these things is the result of squaring something or multiplying something by itself. And there are some patterns between this and this, between these, that I want you guys to be aware of, because we're going to want to create in the next section, trinomials that are perfect squares. And here's the relationship. The relationship is, assuming that the lead coefficient is always 1. So that's if the lead coefficient is not 1, what I'm saying is a lie, but we're not doing that in this class. So just know this, what I'm telling you is kind of a half-truth, but it will apply for everything in this class. When you have a perfect square trinomial with a lead coefficient of 1, it's always the case that half of this number squared is this number here. If I take half of 6 is 3. If I square 3, I get 9. If I take half of this number and square it, I get this number over here. Half of 10 is 5. 5 squared is 25. It's true for every single one of these. This number, if I take half of it and square it, I get 1. Half of negative 8 squared is 16. And that's how we get to look at something and tell if it's a perfect square trinomial. If half of this term squared equals the last term, and the lead coefficient is 1, then we have a perfect square trinomial. The other relationship I just want to point out quickly is this number over here, this number over here, over here, over here, it will always be half of this. It will always be the square root of this. This 5 is half the 10. It's the square root of 25. This 1 is half of 2. It's the square root of 1. This 4 is half of 8, the square root of 16. So, but the big one is this number will always be half of this number squared. So I could say it over and over again. It's starting to get a little monotonous, I'm sure. But it's got to sink in, and you'll see it enough. You'll forget it, and then you'll be like, oh yeah, that's right. That's what he said 50,000 times. So this is one of those things where it's when you're looking right at it and someone's telling it to you, you're like, yeah, I get it. But when you have to actually apply it, you forget it, and then when you see what the person did, you're like, oh yeah, that thing, and then eventually it will stick.